Hi future doctors, welcome to the next class. In this class we will discuss about magnetic moment. Magnetic moment of coil, circular coil. So already we discussed this magnetic field intensity on the axial line due to current carrying circular coil. In that we got this formula. What is this formula? So M is going to be equal to NIA. So NIA. What is NIA? Number of turns. So M is going to be NIA. N is going to be number of turns. I is going to be current passing through the coil. A is area of the coil. If current is passing in anti-clockwise direction in a coil of radius R, so this one will be acting as which pole we said? Anti-clockwise means. Anti-clockwise means in that N will be there, therefore it is acting as north pole we said. Correct? So we are discussing magnetic moment. For one turn, capital M is going to be I into A, so I into pi r square. Then why we give current direction anti-clockwise north pole means magnetic moment is a vector quantity. Now current is scalar, now area is the direction. Isn't it? It is having direction. And magnetic moment is having direction. In the direction, this area also we should take. So what is the direction of this magnetic moment? How we will calculate means, again, keep our four fingers in the direction of current. Thumb is going to represent direction of magnetic field. In the direction of magnetic field, magnetic moment will be there. Now what is the direction of magnetic field means? Outside. This is acting as which pole we said? North pole. So for you it is going to be anti-clockwise for this side means other side people, how that one will be acting means it is going to be clockwise. Therefore, so for other side, so if you are taking loop like this side you will be having south pole, this side you will be having north pole. So you will see. So if this is the loop means, so if current is passing like this, now thumb is going to be towards you, isn't it? So now for you, this is going to be acting as which pole? So this is going to be acting as north pole for this side. So if you are viewing from this side, it is going to be acting as south pole. So the direction of magnetic field south to north. Therefore, direction of magnetic moment is also south to north. We will say. So that direction is going to be away. Away means along this side, what will be there? I cap, J cap, K cap will be there. Therefore, that K cap only we will write. So another one also we got one point. So it is from south to north. If current is passing clockwise, okay. Now current is passing clockwise means it will be coming like this. Current is like this, magnetic field is into. Now what is the magnetic moment means? Same. NIA for one turn, it is going to be IA. So M bar is equal to I into pi r square. But direction is going to be reversed. South pole means direction means clockwise means it will be coming as south pole. So again into means south to, for you it is south means for this side people it is going to be north. Again it is south to north. In electric field we said direction of the electric dipole moment positive, negative, positive charge. So dipole moment is in the direction of negative to positive. Same like that magnetic moment of the circular loop south to north. So direction if you want means anti-clockwise means it is going to be away. So clockwise means into. Into means minus k cap. So like this it is going to be. If coil is like this, vertical, and current is passing like this, then see the magnetic moment direction will be left side. Left side means minus I cap. So current is going coming like this. Loop will be like this. Then thumb is going to be right side. Therefore, magnetic moment will be right side. So if current loop is like this, horizontal plane, then upwards. Current is going like this, downwards. Depending on the position, loop, direction, we are going to get. So this is circular. If you want to get like this, So current is passing like this. This is L, this is B. Now, what is the direction of this current carrying loop magnetic moment direction? So M is equal to I into A for one term. Current into what is the area? Length into breadth. Now, what is its direction? So you can take like this clockwise. Therefore, magnetic field is into. Into means minus K cap. So depending on this coil, we are going to get like this. Understood? So this is how to take direction of the magnetic moment and what is the formula for magnetic moment. So everyone will be coming to know this formula NIA. Next we will see magnetic moment of revolving electron. If electron is going to be revolving in circular path of radius capital R. So one electron is revolving. For one revolution, what is the current produced by this electron? This one we discussed in current electricity. So I is equal to Q by T. So I is equal to, so E by, what is time taken to complete one revolution means time period. If it is moving with velocity V in circular path, for one rotation, velocity equal to 2 pi r by T, distance by time. Then T is equal, because it should move with constant speed, 2 pi r by T. T is equal to 2 pi r by V. So if you substitute here E by 2 pi r by V, then what you are going to get means I is equal to EV by 2 pi r. This is the current produced by revolving electron for one revolution. Already this formula we have previously in current electricity. Okay, once we got current, area we came to know. Therefore, magnetic moment is I into A. For one revolution means for one turn. So I means EV by 2 pi r. A means pi r square. Therefore, if you cancel 1 pi, so EV r by 2. This is the magnetic moment of revolving electron. If charge is going to be revolving, very important for charge Q, what we will write this magnetic moment means QVR by 2. This is only for charge, this is for electron. So whenever electron is revolving, Bohr will not accept us. So Bohr postulates we came to know. So second Bohr postulate, whenever electron is revolving or any object is revolving, angular momentum L is equal to MVR is equal to what he said, NH by 2 pi, according to Bohr's second postulate, isn't it? Angular momentum of revolving electron around nucleus is always equal to NH by 2 pi. Now, magnetic moment by angular momentum of this revolving electron I am saying. So, EVR by 2 by what we got? MVR. So, VR will be cancelled. Can we cancel? Then what we are going to get? Here E by 2m. This is the ratio of magnetic moment and angular momentum we will call gyromagnetic ratio. So E and M are constant. If you substitute, you are going to get this value is going to be constant. So this they are going to ask in problems for charge once again. For charge Q, M by L is equal to Q by 2M. So how they will ask questions, we will see. This is gyromagnetic ratio of magnetic moment and angular momentum of revolving electron. So for electron, it is going to be E by 2M. So already E by M we came to know. This is called specific charge of electron. So half of specific charge of electron is also gyromagnetic ratio we can say. Next, from here, if you are taking gyromagnetic ratio, M by L is equal to E by 2M. So you have to understand, whenever I am writing E, that is for revolving electron. Whenever I am writing Q, so charge is revolving, that one is going to be very important. So M is equal to E by 2M into, yeah. So E by 2M, what is capital L here? In place of this MVR already we used NH by 2 pi we are writing. NH by 2 pi. So this is going to be NEH by 4 pi m. This is the magnetic moment of revolving electron, because I wrote here electron. So in hydrogen atom, in first orbit, if n equal to 1, m is equal to EH by 4 pi m. So E value, H value, m value, mass of electron, Planck's constant, charge of electron if you substitute. So one value you are going to get 9.27 into 10 power minus 24 ampere meter square. So you can calculate that value. So this value we are going to call it as Bohr magneton. Bohr magneton. What is Bohr magneton means? So the magnetic moment of revolving electron in first orbit of hydrogen atom. The magnetic moment of revolving electron in first orbit of hydrogen atom is called Bohr magneton. So this value is going to be constant. Nearly this one you will get once you can cross check after substituting all these values. Yes, this value is going to be correct, 9.27 into 10 power minus 24 magnetic moment of revolving electron in first orbit of hydrogen atom. So sometimes they will give directly this formula, magnetic moment of charge which is revolving. Sometimes they will ask gyromagnetic ratio E by 2m. Otherwise on this they are going to ask questions, m by L is equal to q by 2m. So you should come to know angular momentum. This angular momentum may be related for first year. First year we came to know L is equal to I omega. What is I? Moment of inertia. Omega, angular velocity. Moment of inertia of ring, disc, solid sphere, hollow sphere, disc and ring. So this I may be anything, this charge may be on anyone. How they are going to ask questions? We will see whenever we are doing problems. So this is about magnetic moment of revolving electron and magnetic moment of different loops. If you know current and area, you are going to get magnetic moment, and the direction is also going to be very important, because magnetic dipole moment is having direction, it is having vector quantity. For magnetic dipole means loop we set south to north, because this one will be helpful in our magnetism and matter also. Therefore I gave the direction. Okay, I hope you people understood. Thank you.